Okay, this is the video lesson for Geometry 6.4, Properties of Rhombuses, Rectangles, and Squares. So here we're going to talk about, these are special parallelograms, right? So a rhombus is a parallelogram that has all four sides congruent. A rectangle is a parallelogram with four right angles. And then a square is kind of both of these. All four sides are the same, but it also has four congruent angles. So there's a square. Okay, so square is also a rectangle, and a square is also a rhombus. All right, so let's look at this first problem here. Is ABCD a rhombus, rectangle, or square? So here, remember these are named by the vertices in a row. That's why this is ABCD, ABCD. You would never name this ACBD, just FYI. Okay, so here we have a parallelogram here. So they're saying this is a parallelogram, right? We're just looking at this parallelogram. That's what the symbol is, ABCD. So what we know about parallelograms are, right, opposite angles are congruent. So if this is 90, this has to be 90. In parallelograms, the sides have to be parallel, right? And so by same side interior angles, these have to add up to 180. So these two have to be 90, and then opposites are 90. So all four sides, angles, are congruent, so it is a rectangle, right? All four angles are 90 degrees, or congruent. Okay, so now it's your turn. This is a parallelogram as well, this EFGH. See if you can figure out if it's a rhombus, rectangle, or a square, and explain. Okay, press pause, try this on your own, and then check back for the solution. Okay, hopefully you figured out this is a rhombus, right? Because it's a parallelogram, right, opposite sides have to be congruent. So then if these two are congruent, then opposite sides are congruent. They're all congruent. That means it's a rhombus. And this is something I didn't say in problem 1, but I will go back to that and say this too. But we don't know about the angles here, so we can't say whether or not it's a square. And then same with here, we only know about the angles. We don't know about the sides, so we can't say if it's a square. That's why this is a rectangle and this is a rhombus. Okay, so another property of a rhombus is that the diagonals are perpendicular. Okay, so if you have a rhombus and you connect the diagonals, they're always going to connect at 90 degrees. So AC is perpendicular to BD. And then another property of rhombi or rhombuses is that the diagonal bisects a pair of opposite angles. So the diagonal right here, these two are the same. And you can kind of, actually the proof of this is pretty obvious, right? This is an isosceles triangle, right? These two sides are congruent. So then these two angles have to be congruent. These are the same. So this is another isosceles triangle. These two have to be the same. So then you also, and they're also side by side, they're congruent. So then these angles have to be congruent. And these ones, the same thing works there. Okay, so that's how this works. So if you know that something's a rhombus, you know you can connect the diagonals, and you know you've bisected all of the angles. These four are the same, these four are the same, and then they're 90 degrees in the middle. And then you can solve lots of problems with that. So let's see an example of that. So here we are given that this figure here is a rhombus. So, and we're given just one angle. And look what you can figure out, right? It's a rhombus. So these four have to be 90 degrees. So we know that the measure of angle 1 is 90 degrees. Then we know that opposite angles are congruent. So this has to be 58 and this has to be 58, right? And this is 58, but that's not 1. So we know measure of angle 2 is 58. Let's say degrees. Measure of angle 3, also 58 degrees. And then because this makes a triangle, and all three of those angles add up to 180, you can just take the measure of angle 4 is going to equal 180 minus 90 minus 58, which is 32. So that's how that works. Here's one to try on your own. Press pause and check back for the solution. Okay, so for this one, 1, 2, 3, and 4 are all congruent. We know that because it's a rhombus and they're opposite. This has to bisect. And since this is 104, we know this is an isosceles triangle, so these two have to be the same, and all three have to add up to 180. So if you subtract 104 from 180, you get 76 divided by 2. It's 38, and all four are 38. Hopefully you got that. Moving on. And then a property of a rectangle, the diagonals are congruent. So they don't bisect, but the diagonal length is congruent. So when we use this property, here this question says, in rectangle RSBF, SF is this expression, RB is this expression, what is the length of diagonal? So I think it's helpful to draw. For this, we know the diagonal. These are just so you can see that they're diagonals. Maybe we know that this is going to be a diagonal problem. But maybe you don't, and maybe this is on a test and you don't even know what section this is on. So you should just draw this. And remember, right here, just pick one to be R and then just go around. S, B, F. And that will have you draw it correctly. You could have started here and it just would have worked out the same. But SF is going to be this diagonal. That's 2x plus 15. And then RB is this diagonal, 5x minus 12. We know that they are congruent because they are a rectangle, so we set them equal to each other. And then we solve. Subtract 2x from both sides. We get 3x minus 12 equals 15. And then add 12 to both sides. We get 3x equals 27. And then divide by 3. You get x equals 9. But it's asking what's the length of the diagonal. So even though we got x equals 9, we don't stop there. That's not the answer, right? We plug it in. We put in 2 times 9 plus 15. That's my SF. So this is going to be 18 plus 15. 33. So we know this is going to be the answer. Let's just, or we assume, we have it here. So let's just double check that we did everything right. And we should get 33 here. 45 minus 12 also equals 33. So we did it right. It's 33. Okay. So here is, ooh, weird. Here's one for you to try on your own. The picture is here. It's a little bit different, but try this, press pause and try that on your own and then check back for the solution. Okay, so actually the picture just looked a little different, but the problem is exactly the same, right? The two diagonals are congruent, so you set them equal to each other. Solve, you get x is 15, but then you need to, right, the question's asking for the length of the diagonal, so plug it back in. Check it for both, so you don't, so let's make sure you did it right, and it's 43. Okay, that's it. Just 5 problems for practice. Enjoy.